Hello ladies and gentlemen. In this video I want to talk about three aspects of the syntax of symbolic logic. In particular, I'll talk about the subformulas, scope, and what it means for an operator to be the main operator of a propositional logic well-formed formula. So in an earlier video we saw that increasingly complex formulas can be built up from the language of propositional logic's formation rules. These are the grammatical rules that allow us to create or form well-formed formulas. It'll be convenient to talk about parts of these well-formed formulas. That is, it'll be convenient to talk about subformulas of certain well-formed formulas. So the definition of a subformula is any well-formed formula that occurs as a part of the well-formed formula in question. So let's look at some examples. In the first example, P and not P are subformulas of the woof not P. P is a part of not P, and so it's a subformula of not P. And not P is a part of not P, since every formula is a part of itself. Similarly, P, Q, and P or Q are subformulas of the well-formed formula P or Q. You notice that P is a well-formed formula, Q is a well-formed formula, and both of these are found in the well-formed formula P or Q. In addition, once again, since every formula is a subformula of itself, P or Q is also a subformula of P or Q. The other examples sort of illustrate this as well. Provided a formula is a part of a more complex formula, then that formula will be a subformula of it as well. Some well-formed formulas are composed of multiple instances or occurrences of the same operator. So, for example, if we had not P, right arrow Q, you'll notice that there are two instances of the not operator or negation operator. For convenience, we'll refer to each of these different instantiations or instances of that operator as an occurrence of that operator. Next, I'd like to talk a little bit about the scope of occurrences of operators. So the scope of an occurrence of an operator in a well-formed formula, let's say it's P in the language of propositional logic, is the smallest subformula of P that will contain that occurrence of that operator. So some examples are helpful to understand this. So we saw that P and not P are subformulas of not P. So the scope of the not operator is not P, because this is the smallest subformula of P that contains that occurrence of the operator. So if you look at the two subformulas of not P, there's P and then not P, only one of these has the not operator. And since the smallest occurrence is the not P, it's the only occurrence actually, the scope of the negation or not operator is the not P. In the case of P or Q, there are three subformulas, but only one of those contains the operator for or the V, and that's the P or Q. In the case of not P or Q, the scope of the not applies to not P. Even though the not P occurs in not P or Q, the smallest occurrence of not P, that is the smallest subformula of not P or Q, is the not P. The scope of not the negation only applies to P, whereas the scope of the V applies to not P or Q. Lastly, in the case of not P, right arrow Q, the scope of the right arrow operator applies to P right arrow Q. This is the smallest subformula of not P right arrow Q that contains that right arrow operator. While the scope of the negation or the not is the whole formula. The whole formula is the scope or the smallest subformula that contains the negation operator. So the last thing I want to talk about is what it means for an operator to be the main operator. Now the main operator, as you might guess, is the operator that has more scope than any other operator found in the formula. It is the truth functional operator in the language of propositional logic with the greatest scope. So let's look at some examples. The first example, in the case of not P, the main operator is the negation because it's the only operator found in the formula. The main operator of P and Q is the AND or caret operator. This again is because it's the only operator within the formula itself. Now in the case of not P or Q, we have two different operators that could potentially be the main operator. There's the negation and there's the operator for or V. But you'll notice that the operator with the most scope is the V, because the operator for negation only applies to the not P, not the whole formula, but only to the not P. Finally, the main operator for not P right arrow Q is the negation or not operator. The right arrow has its scope P right arrow Q, but the negation operator has its scope the whole formula, so it's the operator with the most scope. Alright, ladies and gentlemen, this has been another video on the language of propositional logic. Like the video if you thought it was helpful, and subscribe if you're interested in seeing more videos on topics in logic.